Hello, my name is Haley and I'm a food science major from the class of 2019.
And my name is Jamie, and I am an animal science major from the class of 2018. We will be working through problem number 2 from chapter 4.3 in the General Chemistry Workbook. You should begin by working on the problem yourself to see if you can get the answer. Pause the video now until you have completed the problem. Then we will go over it together.
We are going to first have to balance the reaction because in problems like this, when you're going to convert between different compounds, you're going to need molar ratios, which we can get from a balanced equation.
Because nothing is created or destroyed during a reaction, there should be the same amount of elements on either side of the arrow. First, we will start by looking at the hydrogens because there are only in one compound on either side of the reaction. On the reactant side, there are 12 hydrogens, but on the product side, there are only 6 hydrogens. Therefore, we need a coefficient of 2 in front of the compound with hydrogen on the product side to get 12 on each side.
Next, we can look at carbon. We have 6 carbons on the reactant side. And with the added coefficient, we have 5 carbons on the product side. So we need to add one more carbon. By putting a coefficient of 2 in front of CO2, we now have 6 carbons on each side.
Lastly, we need to check and see that the number of oxygens are balanced on each side. On the reactant side, we have 6 oxygens. And in the first compound on the product side, we have 2 oxygens with the added coefficient, and in CO2, we have 4 oxygens with the added coefficient, which equals 6 oxygens total.
These coefficients in front of the compounds are how we use mole ratios to convert from 1 mole of a compound to another mole of a compound. In this reaction, it means that 1 mole of C6H12O6 breaks down to make 2 moles of C2H6O and 2 moles of CO2.
Let's start with part A. The question is, how many moles of CO2 gas are produced when 3.6 moles of C6H12O6 reacts? First, we need to know what we are given in the problem and what we are trying to find. We are given 3.6 moles of C6H12O6, and we are trying to find moles of CO2. To get from moles of C6H12O6 to moles of CO2, we will use the balanced equation to formulate our conversion factors. First, we start with 3.6 moles of C6H12O6. And the balanced reaction tells us that 1 mole of C6H12O6 is equal to 2 moles of CO2. Therefore, the units will cancel out, and if we multiply 3.6 times 2, we get that there are 7.2 moles of CO2 gas.
Now let's move on to part B. This question is, how many grams of CO2 is produced when 36 grams of C6H12O6 reacts? We are given 36 grams of C6H12O6, and we are trying to find the number of grams of CO2. We will use the molar ratios and the molar masses based on the periodic table of each compound. To get from grams to moles, we can use the periodic table and add the atomic masses together of each compound because the molar mass has units of grams per mole. The molar masses are found below each element of the periodic table, and you can add those up and multiply by the subscripts to get the molar mass of the whole compound. So for C6H12O6, the molar mass is 180.16 grams per mole. And for CO2, the molar mass is 44.01 grams per mole. So we should start by writing 36 grams of C6H12O6. And to get from grams to mole, we're just going to use the molar mass. So we have 180 grams per 1 mole of C6H12O6. And to get from moles of C6H12O6 to moles of CO2, we multiply by the molar coefficients. So 1 mole is equal to 2 moles of CO2. And to get back to grams, we want to use carbon dioxide's molar mass. So we're going to do 1 mole of CO2 is equal to 44.01 grams of CO2. Based on that, we can cancel out some of our units, so we know we're left with grams of CO2. So our grams of that cancels out, our moles, and then our moles of CO2 cancels out, and we're left with grams of CO2. And if you multiply that all out, you should get 17.6 grams of CO2.
Part C asks how many grams of CO2 are produced when 2 moles of C2H6O are produced. Here we go from moles of a product to grams of another product. Therefore, we start out with 2 moles of C2H6O, and we are trying to find grams of CO2. Therefore, we'll start out with what we were given, which is the 2 moles of C2H6O. And we will use the molar ratio to get from moles of C2H6O to moles of CO2, which we know that for every 2 moles of C2H6O that are produced, there are also 2 moles of CO2 produced. Then, to get to grams of CO2, we will just use the same molar mass we used from part B, and from that we know that for every 1 mole of CO2, there are 44.01 grams of CO2. From this, our moles of C2H6O will cancel, and our moles of CO2 will cancel, which will leave us with grams of CO2. And if you multiply this out, you will end up with 88.02 grams of CO2.
Now let's look at part D. It asks how many grams of C6H12O6 would you need to make 1.6 kilograms of C2H6O. So we have 1.6 kilograms of C2H6O, and we're trying to find the number of grams that is needed to make C6H12O6. So we're going to start out with what we're given, and we're going to multiply that by the conversion factor written above to get from grams to kilograms. So if we have 0.001 kilograms, that's 1 gram of C2H6O. And to get from grams to moles, we're just going to multiply by its molar mass. So 46.07 grams is 1 mole of C2H6O. And to get from moles of that to moles of the other one, we're just going to multiply by the molar ratios. So we have 2 moles of C2H6O is going to be making 1 mole of C6H12O6. And then lastly, to get back to grams, we're just going to multiply by that's molar mass. So we have 1 mole is 180.16 grams of C6H12O6. And then some of our units are going to cancel out, like our grams, our moles, and our moles. And then we're left with 3,128.5. And then lastly, we didn't cancel this out, so we have grams of C6H12O6. I hope this video was helpful, and have a great day.